A ratio is a comparison of two like quantities. Ratios don't have any units. That's because in ratios, the units are the same. For example, if a recipe calls for amount of flour in grams, the amount of sugar will also be given in grams. But if the amount of flour is given in cups, the amount of sugar will also be given in cups. A rate is a comparison of two unlike quantities and therefore will always include units. Some rates used in everyday lives include driving speed, heart rate, and wages. We see that rates show the relationship between two different quantities. Equivalent rates are just like equivalent fractions but with units. We can use equivalent rates to find the missing quantity. If Lynn is driving 45 kilometers per hour, we can find how far she would drive in 2 hours. If we multiply 1 hour by 2, we get 2 hours. Then we have to do the same to the distance. 45 kilometers times 2 is 90 kilometers. So she will travel 90 kilometers in 2 hours. Notice that we use a constant rate of change or constant speed, meaning that every one hour she will travel 45 kilometers. Jack is typing 75 words per minute. How many words can he type in 1 hour? The rate is 75 words per 1 minute. Now we have to find how many words he can type in 1 hour. When using equivalent rates, we need the same unit for time. We're going to change 1 hour into minutes. We know that 1 hour has 60 minutes. Let's multiply 1 minute by 60 to get 60 minutes, and we have to do the same to the numerator, times 60. 75 times 60 is 4,500 words per 60 minutes or per 1 hour. Jack can type 4,500 words in an hour. Another way to find the missing quantity is to use the rate as a conversion factor. Let's look at example 2. Coco is reading 42 pages per 54 minutes. We have our rate, 42 pages per 54 minutes. We want to find how many pages he can read in 1.5 hours. We have 1.5 hours, and he reads 42 pages in 54 minutes. We must have the same unit for time. Once again, let's convert hours to minutes. 1.5 hours is 90 minutes. Note that our conversion factor, this rate here, has minutes in the denominator. And that is so we can cancel the minutes from the time given. Remember, minutes divided by minutes is just 1. We end up with the pages, which is the unit that we want to get. 90 times 42 divided by 54 is 70 pages. So Coco can read 70 pages in 1.5 hours. A car travels a distance of 280 kilometers in 3.5 hours. This is our rate. This is our conversion factor. Calculate how far it will travel in 1 and 1/4 of hours. We are given the time of travel, 1 hour and a quarter, so 1.25 hours. We are given the rate, how fast he's traveling. He travels 280 kilometers in 3.5 hours. And we need to find the distance traveled, how many kilometers. Let's start with 1.25, and don't forget the hours because in this method, the units will help us. Now, we have to use this conversion factor. We know that hours must be in the denominator because we can cancel them out. We're looking for kilometers, not hours. So 3.5 hours, and we put 280 kilometers in the numerator. 1.25 times 280 divided by 3.5 is 100 kilometers. So he will travel 100 kilometers in 1.25 of an hour. Let's look at another example. A car travels a distance of 280 kilometers in 3.5 hours. Note this is the same rate, same speed. Calculate how long will it take to travel 480 kilometers. In this question, the distance is given, the speed, the rate of how fast it travels is given, and we have to find how long it needs, the time. Let's start with 480 kilometers. Now we're going to use our rate, our conversion factor. We have to cancel the kilometers. We have to cross the kilometers. So kilometers go into denominator. 280 kilometers in 3.5 hours. And we get 6 hours. So it will need 6 hours to travel 480 kilometers. Sarah works at a restaurant. She gets $12.80 each hour. If she works for 8 hours and 45 minutes in a day, how much money will she earn per day? We are given the time of her work. She works for 8 hours and 45 minutes. Remember, there are 60 minutes an hour, so 45 minutes per hour. So that's the time times she makes $12.80 per hour. Per 1 hour, we put the hour in denominator so we can cancel the hours because we're looking how much money she will get. Now this is 8 hours and 45. We're going to reduce this fraction. We get 8 hours and 3/4 hours, which is 8.75. We already canceled the hours, times 12.80. So she will get $112 for the day of work. Remember that we have to use the units and the hours get cancelled. Let's try another example. If 3 bagels cost $4.50, this is our rate. 3, let's use B for bagels, cost $4.50. Remember that we can also write it as we pay $4.50 per 3 bagels. So sometimes we're going to use the first rate Other times we're going to use the other rate. What is the price? So we're looking for the price of 7 bagels. So we have 7 bagels. We have to use one of those conversion factors. Since we want to cancel the bagels, we put bagels on the bottom. We have to use this conversion factor. $4.50 per 3 bagels. Bagels cancel out and we get $10.50 for 7 bagels. Kiki wants to buy 5 cookies. She can buy 4 cookies for $2. This is our rate, our conversion factor. $2 for 4 cookies. Let's use C for cookies. Sometimes we must use 4 cookies per $2. So it depends on what we're looking for. Here we have to find how much does 1 cookie cost. So here we have 2 questions. We want to find the price for 1 cookie and we want to find the price for 5 cookies. If it's only one cookie, and we know that this is how much we pay for 4 cookies. So if 4 cookies cost $2, cookies cancel out. 1 times 2 divided by 4, that's 50 cents. If we want to find the price for 5 cookies, we can either multiply 50 cents by 5, or we can start with 5 cookies. The rate stays the same, $2 for 4 cookies. Cookies cancel out. 5 times 2 divided by 4 is $2.50. And let's try one more question. The Dodge Grand Caravan uses gasoline at the rate of 12 liters per 100 kilometers. So we have 12 liters per 100 kilometers. How far can the car go on 60 liters? Okay, so we start with 60 liters. And we know that we spent 12 liters for 100 kilometers. But we want liters on the bottom so we can cancel liters out. So we put the 12 liters down and 100 kilometers in the numerator. Now we have 60 times 100 kilometers divided by 12. And that's 500 kilometers. Now, using the conversion factor method is very useful because it works in all the cases. The equivalent rates method works in the nice cases when we have when we can multiply by whole numbers. The unit rate is the rate per 1 kilometer, per 1 day, per 1 liter. So in the unit rate, the denominator must be 1. And it's very useful to compare. For example, we have 2 cars traveling at different speeds. If car A travels at 126 kilometers per 1.5 hours and car B travels for 450 kilometers in 5 hours, it's hard to compare these two. However, if we divide them, so 126 kilometers divided by 1.5 hours, we get a unit rate. We get kilometers per 1 hour, and that's 84 kilometers per 1 hour. Car B travels at 90 kilometers per 1 hour. Since they both have the same denominator, we can see that car B travels faster than car A. Serafina would like to buy 36 lemons. She is looking at two stores, Pirate Duo and Robert Sile. We see that Pirate Duo sells 12 lemons for $3, and Sile sells 8 lemons for $2.40. To see which store gives a better deal, we can either find how many lemons we can buy for $1 or how much we would have to pay for 1 lemon. In both cases is a unit rate. I would like to find the price per 1 lemon. Divide 3 by 12, that's 25 cents per 1 lemon, and Sayo offers 1 lemon for 30 cents. Now we can see that Duo gives a better deal. 1 lemon costs 25 cents compared to 30 cents with Sayo. Of course, we could also complete the first case and find that with Duo we can get 4 lemons for $1, so again unit rate, but with Sayo it's less than 4, only 3.3 lemons for $1. This gives us the same solution that it's better to buy with Duo. Mo read 100 pages of a book in 4 hours, and Bo read 90 pages of the same book in 3 hours. Which girl read faster? Once again, if we're comparing, we have to find the unit rate. Mo read 100 pages in 4 hours. So we can find how many pages in 1 hour. 100 divided by 4 is 25. 25 pages in 1 hour. And Bo read 90 pages in 3 hours. 90 divided by 3 is 30 pages per 1 hour. We see that Bo reads faster. She reads 30 pages per hour compared to Mo, who reads only 25 pages per hour. So Bo reads faster at the unit rate of 30 pages per 1 hour. Mia's parents want to buy a car. They're looking at either Kia 2016 or Nissan 2016. And they test both cars for the fuel consumption. If Kia is using 1.21 liters for 12 kilometers, 1.21 liters per 12 kilometers, and Nissan is using 1.47 liters per 15 kilometers, which car is the better choice based on its fuel economy? Once again, since we are comparing, we want to find how many liters each car will use per 1 kilometer. So per 1 kilometer, 1.21 divided by 12 is 0.101 liters per 1 kilometer, and 1.47 divided by 15 is 0.098 liters per 1 kilometer. So we see that Nissan uses less gas per kilometer. Now complete practice 11 and check your answer when you're ready. We find that Trader Joe's charges 70 cents per one apple, but Farmer Bill charges 75 cents per one apple. So Trader Joe's gives a better deal. For 45 apples, we would pay $31.50 from Trader Joe, but with Farmer Bill, we would have to pay $33.75. Therefore, the difference in price is $2.25. The conversion factor unit method is very useful when we're converting the currencies. If John is selling a smartphone for 200 Canadian dollars, so this is Canadian dollars, this is US dollars, and the conversion or exchange rate is 1 Canadian dollar is 85 cents US. We can write it as a rate. We want to convert from Canadian dollars to US dollars. So 1 Canadian, we want to cancel Canadian out, is 85 US dollars, 0.85, 85 cents. So 200 times 0.85 divided by 1 is 170 US dollars. Andre wants to go to Chicago. He goes to the bank to exchange $50 Canadian and he receives 39 American dollars, US dollars. How much in Canadian dollars does Andre pay for 1 American dollar? We start with 1 American dollar. We're going to use USD, US dollars. We want to know how much he pays in Canadian dollars. And we know that for 50 Canadian dollars, he gets 39 US. So 39 US dollars for 50 Canadian dollars. We put USD, US dollars on the bottom so we can cancel them out. So 1 times 50 divided by 39 is 1.28 Canadian dollars. So 1 US dollar equals to 1.28 Canadian dollars. How much Canadian dollars would Andre have to pay for 75 US dollars? So we want 75 US dollars. How much Canadian dollars we have to use? Okay, we can either use this conversion factor, 1 US is 1.28 Canadian, or we can use again 50 Canadian is 39 US. Let's use the simpler one. 1 US is 128 Canadian. US we put on the bottom because we want to cancel it out. 1.28 Canadian we put on the top. US dollars cancel out. We get 75 times 1.28 divided by 1, which is 96 Canadian dollars. How many American dollars would Andre receive for 100 Canadian dollars? So we start with 100, and we're going to use again for unit Canadian dollars. Once again, we can either use the 50 Canadian equals to 39 US dollars, or 1 US dollar is equal to 1.28 Canadian dollars. I'm going to use 1 US is 1.28 Canadian. We put Canadian on the bottom so we can cancel it out. So 1.28 Canadian is equal to 1 US dollar. We cancel the units and we get 100 times 1 divided by 1.28, which is $78.13 US in US dollars. And we would get the same answer if we used the exchange rate 39 US dollars to 50 Canadian dollars. Now Andre found a phone he wants to purchase from German manufacturer for 1,200 euros. The exchange rate is 1 euro equals to 1.45 Canadian. So 1 euro is $1.45 Canadian. How much does he need to pay in Canadian dollars for the phone? Let's start with euros. And we're going to use EUR for euro. So we start with 1,200 euros. And we're going to use the exchange rate. 1 euro is 1.45 Canadian dollars. We put euros on the bottom so we can cancel the unit euro. We can cancel euros. And we put Canadian dollars on the top because we want the price in Canadian dollars. 1,200 times 1.45 divided by 1 is 1,740 Canadian dollars. Next is a challenge question. Similar questions sometimes show up on different competitions. So let's see if we can figure it out. We have 45 workers who need 75 days to fix a road. After 62 days, 6 workers take a medical leave due to COVID exposure. How many days will the remaining workers need to finish the job after their co-workers left? So in order to complete the job, 45 workers would have to work for another how many days? 75 days in total, but they already worked for 62 days. So they would need another 13 days if all the workers stayed on the job. However, since 6 workers left the job, now we only have 45 workers minus 6. We're left with 39 workers. And make sure you try the solution yourself before you check. So we know that 45 workers would need 13 days, but we don't know how many days will 39 workers need. We know that they will obviously need longer than 13 days because there are less of them. Let's think about it this way. We have 45 workers who need 13 days to finish a job. So this will be a job. Now, if we only have 39 workers, how many days will they need to finish the same job? And since it's the same job, we know that these two equations must be equal. So we can say that 45 workers times 13 days equals to 39 workers times X number of days. We're looking for x, so we need to divide each side by 39 workers. Here, 39 workers cancel out, and the number of days workers cancel out is 15 days, which makes sense because it takes longer than 13 days since we have less workers to finish the same job. You also have another challenge, so good luck and keep practicing.